So, last time, keratinization. Live cells at the bottom, as they come up, they are going to basically die and become dry and waterproof and flaky and very protective. So that's the process of keratinization. Same thing with like your nails. The living part is at the bottom, and as you come outward, they keratinize, and you can cut your fingernails. It doesn't hurt because that outside part is dead. However, if you cut your fingernail way down to the nail bed, that hurts. Those cells are alive, where out at the edge, they're not. So, here, basement is going to be a dark purple at the bottom, and here's your layers upon layers upon layers of squamous cells. Very, very protective. Stratified cuboidal, we're getting into some of them that are not quite as common. So stratified cuboidal, many layers of cube-shaped, 2 to 3 layers typically. Mammary glands, sweat glands, salivary glands, produce saliva. Ovaries, seminiferous tubules are inside of the testes. So a lot of these provide protection, but notice a lot of them are glands, so they're going to probably do some secretion also. And there you can see, not as many layers as your stratified squamous, but there are typically more than one layer. Stratified columnar, many layers of columns. This type is very rare. Typically, it's only going to be found in the male urethra. So it's going to have some stretch to it for urine and fluids to pass through, but not very common. Also, they become more columnar as you go towards the top. This one I will probably not have for test purposes because it is so rare. But notice as it goes towards the outside, it does become more column shaped. Transitional. This one is designed to stretch. So it's going to distend, which means stretch, and then return to its normal size. So therefore, your bladder, urethra, ureters, urinary system, where fluids fill things up and they have to stretch to hold it, transitional epithelium is most likely going to be found there. Its biggest function is distensibility, which is stretching. It's able to stretch. And then go back to its normal size. And there's a couple of pictures. Notice it's not always exactly the same size. You can see when it's unstretched, it's going to be smaller. When it's stretched, it's going to be larger. So those cells actually change shape, like your bladder. When your bladder gets full, those cells actually stretch and elongate. Glandular glands, so secretion, typically going to be cuboidal or columnar. Ducts, so glands that secrete products into ducts are exocrine. These two words will be important. Exocrine go into ducts, some type of duct that's going to leave. Endocrine don't have a duct. They are released freely into the blood or some type of other fluid. So exocrine has a duct. Endocrine does not have a duct. It's going to go into a fluid like your blood. And then those glands that do secrete have different ways of doing it. Merocrine glands release fluid by outside, cytocell, exocytosis. So pancreas, salivary glands, sweat glands, most of these are merocrine glands. Serous is a watery fluid, where mucus is a thicker fluid. So serous, if you've cut yourself and you get that white watery fluid that comes out, that would be a serous. Others, the mucus, are going to have a thicker, more productive substance to it. So merocrine glands use exocytosis. It leaves the cell. Apocrine glands actually pinch off part of their cell. So part of their cell is actually what is released. Mammary glands would be an example of this. So the formation of milk actually comes from cells inside of the mammary glands. And holocrine, or if you want to pronounce it holocrine cells, release their whole entire cell. So they disintegrate. Sebaceous, most of your glands that are going to create oils, that thick oil comes from the entire or whole cell that produces it. And I like these pictures the best to actually show what happens. So if I have a merocrine gland, it simply releases stuff. Out of the cell comes the material that is being produced. So saliva is produced out of these cells. If I have an apocrine gland, so production of milk, actually pieces of the cell or a part of the cell is broken off and released. Holocrine gland, the whole cell eventually just breaks off, and then it's going to disintegrate into smaller pieces and produce the oil that's going to come out. And this table is also in your notes. I'm not going to read through it. This has all of the different epithelial cells on it. And the epithelials are the most diverse tissue in this chapter. And that's where we'll stop. So connective tissues next time won't be nearly as long.